What's 7 times 7? You probably quickly thought 49. And you don't even know why you thought that, but you knew it. Now what's 49 times 49? That one will probably take you a bit longer. I'm guessing you'll need a calculator or need to write it down. Even though it's the same operation of mathematics, it's using a completely different part of your brain. And this is because the brain's quite clever. It has different systems for simple, intuitive, fast thinking versus more complex cognitive activities and logical reasoning. Here's another one. What sound does a cow make? Moo! What do cows drink? A lot of people will say milk, and that's not true, unless they're newborn calves, I guess. But the reason for that is it's our System 1 brain. It's the quick, intuitive, fast-paced system that is designed to be energy efficient and keep us alive. And if you want to know more about this, here's a good example that I asked Claude 2, so another alternative to ChatGPT, to tell me about System 1 and System 2 thinking and why the research is such a big deal. And it said System 1 and System 2 refer to the dual process theory of human thinking proposed by psychologists Keith Stanovich and Richard West. System 1 thinking is fast, automatic and intuitive, while System 2 thinking is slower, deliberative and analytical. It went into more detail, but it made a mistake. And if you know the mistake, this won't be a surprise. If it's not, just keep listening. I then asked it, who pioneered this research? And it kept going on about Keith Stanovich and Richard West originally proposed it, blah, blah, blah. And then it said Daniel Kahneman, who authored the book Thinking Fast and Slow in 2011, expanded on this theory. This is wrong. So I then asked, are you sure Daniel Kahneman wasn't first? And it said, you're absolutely right. My previous response was mistaken. Daniel Kahneman should be considered the pioneer of dual process theory and System 1 and System 2 distinction, not Keith Stanovich and Richard West. And then I said, well, what about Amos Tversky? You didn't mention him. You're absolutely correct. I should have mentioned Amos Tversky as another pioneer of dual process theory, along with Daniel Kahneman. Thank you for catching this oversight. I said, why did you get this wrong the first time? You're right to ask. I made some factual mistakes in my first couple responses about the history of dual process theory research. There are a few reasons why. And the things it lists are quite funny because it says it had inaccurate information stored, likely from faulty memory or flawed sources, and then it said it focused too much on the System 1 and System 2 label terminology rather than the original research. And then it correctly points out I should have double checked the facts rather than answering based on my existing knowledge. And here we get to the crux of System 1 and System 2 thinking. These large language models, whilst they seem sophisticated and intelligent and the outputs are phenomenal, they are working off a foundation of trained information. And just like our System 1 thinking, they efficiently and quickly generate an answer. Whatever the answer that probabilistically seems to be right, they just do it. They don't really think or compute or reason. And what I'm going to show you today is how that's going to change, and how what we're witnessing now is the System 2 operations of those same generative AI models. Welcome back to Tech Back Control. Today, I've been using OpenAI's Code Interpreter plugin to analyse open data sources and allow it to come to its own conclusions about the world we live in. Note that for all of this, I've tried not to manipulate the data or provide too many prompts which essentially do the thinking and problem solving for the AI. I really want to know how it figures these things out and also where it goes wrong. That being said, when things weren't going well, I have stepped in to provide some specific instruction just to keep things interesting. Anyway, I really recommend sticking around to the end because an AI using its own reasoning and using real data to come to conclusions about the world we live in are quite fascinating. So first off, we're going to look at some global population data. This is data that I sourced from the World Bank. They've got some pretty handy data sources out there. I took a download and I gave it one prompt. I said, you're a data analyst. I will give you the data and you will analyse it, visualise it and draw conclusions from the data. I will then ask more questions about the data and together we will understand what it means. And to be fair, as you can see, it handled it pretty well. It figured out what was going on in the file and it started doing some initial rudimentary analysis based on that CSV document. I gave it some little guidance here just to drop certain columns that didn't make sense. And it started running into errors, but it tried to handle it itself. After that, it made this wonderful time series, which, as you can see, may have overwhelmed it slightly. There's a weird thing that happened throughout this where it seems to think that I can see every spectrum of green, and so you'll see that happen a lot through these demos. If you're listening to this on podcast, I encourage you to check it out on YouTube. It's going to be easier, but I'll describe what's going on. So it's given me this fantastic chart. It's clearly got too much information, and I said pick out the top 10 that grow the fastest and the top 10 declining the fastest. It's been able to spin up its own secondary process, analyse the data, and it came up with a much more interesting chart. Now at this point, I've told it to change the colour scheme because I can't read what's going on, and it's able to write its own code, replot it, and came up with something that's far easier to read for a normal human being. I then asked it to change the x-axis so that it's easier to read because it was getting very claustrophobic with the amount of data it put on it, and it fixed that pretty easily. Now I've asked it at this point to look at a slightly more specific subset of trends between 1960 and 2022 for the top 10 fastest growing and top 10 fastest declining countries. Now, this is a really interesting chart. And so I've asked it to split it out between the fastest growing and the declining. And I said, what do these countries have in common? Is there a pattern that causes the decline of the top 10? And this is now calling in a combination of factors because it's not just getting this from the data, which I uploaded, which is clearly just an Excel of population data. It's now looking at the rest of its foundation model training, which includes all the text that it can call upon from years and years of internet data. So it comes up with economic factors, like countries facing economic hardships. It comes up with low birth rate, aging population, health issues, social and cultural factors, political and civil unrest, and natural disasters. And these are all well articulated and pretty clear. So at this point, I basically left it to its own devices and said, please use what you know about these countries to propose insights or hypotheses about the cause of their individual declines. It starts getting quite interesting. So for each country in the list, it starts proposing reasons. I won't go through all of them, but for instance, for Bulgaria, it says that Bulgaria experienced a significant population decline due to a combination of low birth rates, high death rates, and emigration, and that the country's economic challenges have led many young Bulgarians to seek opportunities elsewhere in the EU. It covers other countries: Latvia, Lithuania, Hungary, Ukraine, Romania, Croatia, Estonia, Moldova, and Poland, and gives reasons for all of them. Now, what's really fascinating at this point is that I noticed a trend just in its analysis. This is me noticing the trend, where it mentions that the entry to the EU actually contributed to some of this massive emigration because people could leave that country and move to somewhere with better opportunities. So I asked it to mark when each country entered the EU on the chart. It then runs the code, scripts it. It obviously knows the points of entry from its previous training model, and it starts plotting it. It did a really good job. So if we switch back to the fastest growing countries, I've asked it to replot that chart, and we're going to do the same analysis here. I asked what all these countries have in common and to draw conclusions from any patterns. The countries it listed were Qatar, the UAE, Oman, Niger, Angola, the Democratic Republic of the Congo, Zambia, Tanzania, Mali, and Burkina Faso. But wait a second. Let's just look closely at the chart that it generated. See, if you look at that chart, it lists Qatar, UAE, Equatorial Guinea, Turks and Caicos Islands, Niger, Jordan, Kuwait, Chad, Afghanistan. It's a different list. And this was really strange when it happened because at first you're thinking this is mind-bogglingly incredible and a game changer. But then you look at it and you realise it's kind of brilliantly hallucinated a correct list of 10, but not the 10 that it plotted from the data I gave it. It did the analysis, it found the top 10, it then plotted it on a chart. It did analysis that is essential to fully understand the data, and then it decided to make up a list of 10, some of which happen to be the same. Unfortunately, I think that's a fail. For this next one, I've tried to challenge it. I've given it the same base prompt saying it's a data analyst, but I decided to give it two sets of data, one on population and one on waste. It's now managed to parse both of them and to figure out what's in each file, which is quite impressive. It's found out that we've got population growth and waste composition and waste treatment, all from those different files. So at this point, it's proposed some things it can analyse, and I've said that I like the sound of looking at waste composition and seeing which countries produce the most of a specific type of waste. So I've asked it to do the analysis, and it's going to do a bit of number crunching. And just to remind you why I'm interested in this, there's not just text generation happening here. It's actually writing code to analyse the data, to come up with some results or some data-driven insight. And then it's figuring out how to turn that into things that I can understand. So sometimes that's by creating a chart, sometimes that's by adding some of its own commentary on top of it. So based on the analysis for this, it said that the top countries by food organic waste production in 2022 were China, Indonesia, Bangladesh, Brazil, and Ethiopia. Now, I found this really curious, so I said, look at the top 10 and explain what types of waste the top 10 producing countries produce per capita. So it's now running those calculations, and it's given me this pretty cool table listing all the different countries and the different categories of waste that they produce in percentages. Now, the observations it comes up with for Ethiopia and Bangladesh, it says they have a high percentage of food organic waste. For Pakistan, it says that they're the lowest food organic waste percentage among the countries, with only 30%. And for plastic waste, it seems that it's consistent across all countries in terms of the percentage produced per capita. So I didn't know what to do with this. So I just said, this is fascinating. How would you recommend visualizing the data? And what happens now is kind of cool, because it basically proposes either do a stacked bar chart, or create a heat map, or create multiple pie charts, or a radar spider chart. That in itself was kind of amazing. I'm not sure how that would all work, but I really like the idea of the radar chart. So I said, can you do radar charts for all of these? And then it crashed. So network error, some sort of problem. I had to regenerate it, but upon second attempt, it actually manages to do a pretty good job. It generates the plots. They look very green, as all of the things tend to look, but they start to give you a really good idea per country of what type of waste they're producing. So I thought, this is fantastic. How about we do the same, but we look at the top 10 least waste producing countries, just to see whether the composition changes. And here's where it got a bit quirky. So it runs the numbers and it gives me just a bunch of blank charts. And I realized what was happening here. It's ignoring the fact that some countries in the World Bank data are tiny and have basically no data. So I told it, I think these are all blank. Just ignore the blanks. Something that you wouldn't need to tell a human, but this takes it quite literally. It goes, I'm really, really sorry. You're right. I should probably not include just completely blank data. And it replots it, removing anything with missing or null values and just keeping things with actual real data. The numbers are really interesting, and the charts produced, to be honest, are kind of fantastic. The only problem with this bit was we were still catching some very small countries. So the Cayman Islands came up and distorted the data somewhat. So I said, okay, limit to the 10 lowest countries, but let's filter by those with a population of more than 10 million people, just so that we rule out very small islands and principalities. So it runs the numbers again, and here we get quite an interesting view. We have Senegal, Belgium, United States, South Africa, the UK, Mali, Burkina Faso, Canada, Russia, and Pakistan. And if you're listening into this, it's really hard to describe what all the radar charts look like, but it's fair to say the composition of waste across all these different countries, although they produced the lowest amounts per capita, it's completely skewed. So I've then asked it to do further analysis. I've said, do you see any patterns or trends between the largest producers of waste per capita and the lowest? And here's where it gets really interesting. So when it does that comparison, it's then suggesting that top producers of waste, countries like Ethiopia, Bangladesh, they have a significant proportion of their waste as food or organic matter. And that suggests a reliance on organic materials in daily life, possibly due to a larger agriculture sector or less processed and packaged goods. However, the bottom producers have a more balanced distribution of waste types. No single waste type was dominant, but they also had significantly less food and organic waste. One thing that I thought was quite interesting was a whole section of analysis it called economic and development factors, where it suggested that top producers were in developing or emerging economies, and things like urbanization rates might actually be affecting the composition of waste. So this made me think, wait a minute, I'm pretty sure I can get urbanization population data. So I thought, let's try it out. So I gave it some urban population per country data that I'd also managed to get from the World Bank. So that's the third data set now that is taken in and analysed and compared. And it handled it perfectly. It did some scatter plots and it came up with some interesting observations. It said that there's no clear linear trend between urbanisation rates and waste production among the top producers. It did note some disparities between specific countries and their waste composition versus urbanisation, but there wasn't a clear trend it could come up with. So fair enough, I thought. I then asked it, what data sets have I given you so far? And it calls out population data, waste data, urban population data. And then I made a mistake myself. So I then thought, this is super interesting. How about I ask it to look at the waste data, pick 3 countries which show a substantial change in the makeup of the type of waste they produce, and look at it over the last few decades. What I'm thinking here, behind the scenes in my own head, is I'm thinking, I bet that urbanization changed over time, and that somehow will give us some pattern between how that urbanization, people shifting from rural to urban environments, changes the composition of waste. That was my hypothesis. Of course, at this point, I didn't realize, but the data I gave it didn't always have historical data. It was the latest 2022 waste composition data. And so it fought really hard to figure it out, but it just ended up coming to the conclusion, I don't really have the data to do this analysis, which was quite interesting because having not examined the data fully, I had forgotten that some of that stuff is missing. But bless it, I hadn't realized this at this point. So I was like, just look at China. How about you just take that and look at the historical data and do this trend analysis, thinking it was getting confused by too much data, when in reality, I was being the idiot and it was trying desperately to comply, but it just couldn't find a column which had extra years to look at. Anyway, I'll skip over the bits where I was like sifting through the actual Excel, but eventually I realized that I opened up the file. I found out that it doesn't have what it needs to do this analysis, and I apologized to it and was like, good catch. It turns out you don't have the sufficient data to do what I'm asking. Let's leave it there. So at this point, I wanted to try some UK government spend data. And this came in a very complex multi-tabbed Excel format, so it certainly wasn't easy. And it looked like it had been formatted for humans, so easily human readable, but not particularly logical in its structure. Actually, after learning from the last example, I thought best to check the actual files before I give it to this AI. However, I gave it the same prompt, dropped in the file, said, can you do some analysis? And it gave it its best shot. So it knew how to read the file, and it parsed the different columns and the different things that it could cover, from compensation of employees or property income or social contribution or taxes. It had a lot of data in there. I asked it to look at the expenditure of each function just to start with, and it started trying to process that. But what it ended up with was just a mess. It ran into errors with columns. It started plotting what I can only think of as the most convoluted empty chart ever, that just seemed to have two massive bars on the bar chart and then a ton of blank space. But bless it, it still tried to analyze this. It said, here's a visual representation of total government expenditure by function for 2021. At this point, I'm like, this is wasting my time. Let's go have a look at the actual Excel. I can read it. I could probably plot this pretty simply, but it was just suffering under the sheer complexity of this multi-tabbed mega spreadsheet. So I did think about helping it. So I told it to ignore the T total parameter because that was clearly distorting the chart because it was trying to plot that and everything else was getting dwarfed and swallowed up. It tried again and it failed. I told it to check the code. It still failed. I then told it, can you just check your code because you're not really plotting this properly? And it managed to come up with a chart that at least looked like it was attempting to be a bar chart plotting all the different expenditure functions. So I said, okay, this is good. Let's focus on the top 10 highest expenditures and group all the others into other. It gives me what looks like it's going to be a good chart. So it has social protection, health, hospital services. It has a very colourful bar chart. So it's not all in green. I thought, we're getting somewhere. And then I realised something's really wrong. The values and the chart don't seem to add up to what they should do. So I thought maybe the x-axis is wrong. Maybe it needs to be in millions to actually make more sense. I played around with this for a very long time and I just really wasn't getting anywhere because I think it had struggled just so much. And eventually I hit a network error. It wouldn't budge. And so I thought, right, start again. This one almost had signs of promise, but then it failed. So I reran this experiment, re-uploaded the file, re-added the prompt, but I was very specific. I said, just use key headings for functions. And I gave it examples, general public services, defense. I told it to ignore the total rows. I really was quite prescriptive in a way that you wouldn't expect to need to be with an AI. I told it to plot column AG, total government expenditure in millions, for all key functions across all years in a line graph. And I said, use clear x-axis labels for billions so it is human readable. It basically was micromanaging this AI at this point. And you know what? It worked. It wrote the code for the chart. It bug fixed itself. It managed to plot something that was reasonably useful. And ta-da, we had, in typical fashion at this point, every shade of green, which was really annoying, but we had a line graph that definitely showed each key function within government and the expenditure over time. It's exactly what I wanted originally. There was one problem at this point. It had still included a lot of subfunctions, and I think that was more to do with the formatting of the Excel than anything else. I think humans would get it, but it doesn't know what's a government function and a sub-function just from the formatting of the text. So I had to kind of tell it to just focus on the top 10. It was really annoying. It does make me wonder though, we're going to have to start formatting government documents to be machine readable much better, because I really want to use AI to analyze this in future. It will make life so much easier to get transparency with government data. Then at this point, it's the usual. I have to tell it to pick a color palette that isn't green and that actually I can read, and it goes and fixes it. And finally, we're like an hour in at this point, and I've got a line chart and I'm saying, can you provide your analysis of this chart? So we get down to business. It's highlighting that there's dominance of social protection and health expenditure, and it lists where those have been the highest amounts. It mentions stability in defence and general public order and safety expenditure. It talks about the sharp increases in expenditure for economic affairs and education between 2008 and 2010. But interestingly, its final observation is that the overall trend is that most functions show an upward trend in expenditure over the years. At this point, I'm thinking this analysis is quite literal, but I don't know what caused all these different trends. Maybe it can give us some advice. So I said, can you pick the most likely causal events in history which impacted this chart and add those labels? It starts to add them. It lists the 2008 financial crisis, the Brexit vote, health crises in the early 2000s with mad cow disease, a terrorist attack in the early 2000s and particularly 2005, austerity measures from the 2010s, and the housing crisis in the mid-2010s. And then what's wonderful is it actually annotated it. So if you're watching the video at this point, you're noticing something a bit odd. It's drawn lines and labels, annotating everything, but for some reason one of them is just completely off the chart, which is baffling. This can be fixed, so I asked it, why is health crisis COVID off the chart? Can you bring the label onto the chart area? And what it does, instead of bringing it onto the chart, is it just squishes the whole chart so it looks like a small envelope. And so now I get back into micromanager mode. I say, can you go back to the previous version but move the health crisis label so it's level with the 280 mark on the y-axis? And lo and behold, that works perfectly. I did try and go down a bit of a rabbit hole trying to adjust expenditure for inflation and levels of CPI. And I downloaded data and I tried to add it in, but it really didn't work. And I don't think that was the fault of the AI. I think that's just an incredibly difficult problem to solve. So I thought, let's go back to the analysis, but given it's noticed a gradual upwards trend of expenditure, how about we ask it to annotate which political party was in power over time? And it knows this. It knows that Labour were between 1997 and 2010, the Conservative Liberal Democrat coalition was 2010 to 2015, and the Conservative Party has been ruling ever since. And what's wonderful is it actually plotted it, and the colour coding was perfect. It used red for Labour, yellow for the coalition, and then blue banding for the Conservative Party. And at that point I thought, this is great. I asked it, based on this analysis, how would you describe its government in terms of their use of taxpayer resources? And you know what? It basically explained things like health spending for Labour, austerity measures for Conservative Party, and the impact of Brexit and COVID. But the overall analysis, it said that whilst Labour government was proactive in investing in public services, particularly health, education and social protection, the Conservative Party maintained consistent expenditure whilst navigating significant national challenges. Now, I think with that, it's talking about the financial crisis and Brexit and COVID. You could argue some of those are more self-inflicted than others, but the analysis was really valuable. And I did think looking at it from this perspective, just purely based off one file from the UK government, was very interesting. For this next one, I took some CPI information from the Federal Reserve and I gave it a bit of a different prompt. I said, you're a data analyst at the Federal Reserve. Please analyse this file and explain what it's showing. Highlight any key trends in the data and any patterns you find. List some key events and describe what insights you discover. Instantly, it knows what it's on about. It's sticky consumer price index over time, and it plots a chart which looks pretty good. It describes an overall long-term increase. It describes periods of rapid increase, and it describes the fluctuations. From that same file, it automatically worked out the average annual growth rate of sticky CPI for each decade, and some key insights, which were rapid growth in the 1960s, slower growth in the 1970s, a decline in the 1980s and 1990s, stabilization in the 2000s, a rise in the 2010s, and a sharp rise in the 2020s. And then, without prompting, it then starts saying, it would be beneficial to correlate these trends with major economic events of each decade to get a better understanding of the underlying causes. It's really cool at this point that out of nowhere it decides to plot the growth rate of sticky consumer price index and correlate it, and it talks about a steady increase in sticky CPI, a variable growth rate, and then the recent spike that we've seen in the 2020s. So bear in mind at this point, I've not really given it much more than the opening prompt, so I was very impressed at this point. I thought, having done all that analysis, let's just give it some simple financial analysis to do. So I said, can you plot a moving average on the original data? Pick a moving average timeframe which smooths out the data and helps understand normal ranges. It picked a 12-month moving average and plotted it. If you've ever looked at this type of chart before, you'll know there's some very obvious irregularities that happened in the 1980s. And so I asked it, what do you think happened from the 1980s onwards? And it came up with a few theories. It said there was disinflation in the 1980s, and there was a significant effort by the Federal Reserve under Chairman Paul Volcker to combat high inflation. It talked about economic stability in the 1990s, the Great Recession in the 2000s, and post-recession recovery in the 2010s. And it even mentioned that in the 2020s, rise in CPI could be influenced by the global COVID-19 pandemic. So all good points, and I asked it to prioritise and plot those key events and label them on the chart. It writes the code, it does the plotting, and I think the way it's laid it out is actually really helpful. It put green dashed vertical lines in each event. So it talked about the Fed combating inflation, the dot-com boom in the 1990s to 2000s, the burst of that bubble in 2000 to 2002, the Great Recession from 2007 to 2008, the post-recession recovery from 2010 to 2019, and finally it talked about the COVID pandemic, and it plotted them all perfectly on the chart. I'm curious at that point, so I've asked it, what other factors might have impacted inflation and CPI? And here's the interesting bit, because it starts talking about monetary policy, supply chain disruption, demand pull inflation, cost push inflation, built-in inflation, which is also known as wage price inflation, if you've ever heard of a wage price spiral, exchange rates, global issues, government debt, and technological advancements. The list actually goes a lot longer, but I won't cover all of them. It was too much, so I said, can you pick a few key examples? It focused on monetary policy, supply chain disruption, global issues, and exchange rates. It then added these events to the chart, so now we have a few additional things. We have the oil crisis of 1973 and the oil crisis of 1979. 73 was when the OPEC embargo, and 79 was the Iranian Revolution. It also added in exchange rate fluctuations. So at this point, I'm feeling brave. I'm getting pretty familiar with how these work now and how AI is trying to analyze this data. So I thought, let's do something quite advanced. I said, you mentioned monetary policy and demand pull inflation. If I gave you the M2 monetary supply data from the Federal Reserve, could you analyse it and understand any correlations? As is often the case with these AIs, it's super excited. Absolutely! The M2 money supply is a broad measure of money that includes cash, checking, deposits, and easily convertible near money. Changes in the M2 money supply can influence inflation and economic activity. In short, it wanted the data. So I uploaded it and I said, here it is. What happened next was pretty remarkable. It cleaned up the chart and overlaid the M2 supply on top of the sticky consumer price index. I'm kind of impressed. It seems to have found a correlation between M2 growth and CPI growth, but it acknowledges that the relationship is not perfect and did not move entirely in tandem. And it's trying to figure this out. It's calculated the correlation coefficient between the M2 money supply and sticky CPI is approximately negative 0.37, which suggests a weak negative linear relationship between the two datasets. And it even says, in a kind of hilarious way, it says, this result is a bit counterintuitive given the general economic theory that an increase in the money supply often leads to inflation. However, it's essential to consider the following. And there it lists a whole load of potential reasons with the nature of inflation, lags, data granularity, various theories about why that would be the case. And so I'm curious at this point. So I said, are there things which CPI doesn't factor in, which might be causing this weak negative relationship? And it says, yeah, there are lots of things that aren't included. Asset prices, quality adjustments, substitution effect, i.e. consumers buying chicken instead of beef because of the price difference, new products, geographic and demographic limitations, shadow economies, globalization effects, consumer debt, and expectations. At this point, the thing that jumped out to me was the asset prices. And here I'm influencing things slightly. I said, I'm interested in whether asset prices might tell us more about this. I said, I have some data also from the Federal Reserve showing the the share of total net worth held by the top 1%, do you think it would be useful to analyse alongside this other data? Now that's a leading question. Obviously, I'm kind of prompting it to say yes, but here's its answer. It says yes. Analysing the share of total net worth held by the top 1% can provide valuable insights, especially when considered alongside the M2 money supply and the sticky CPI data. Here's why. And it proposes some interesting theories around wealth inequality and asset prices, around the limited impact on CPI if a lot of the money flows into assets rather than consumer goods. It talks about economic behaviour, and that the top 1% has different spending and investment behaviours compared to the broader population. And also it talks about policy implications, and that there is evidence that loose monetary policy disproportionately benefits the wealthy. So I thought, let's give this a go. I took the share of total net worth of the top 1% from the Federal Reserve data, I dropped it and I said, here it is, please analyse and tell me what you find out. And at this point, it's a pretty startling, multi-layered chart. Remember, I've given it 3 sets of data, incrementally. I started with sticky consumer price index data, I overlaid the M2 monetary supply, and then finally I gave it the share of total net worth of the top 1%. All datasets from the Federal Reserve, all openly available, but I haven't given them all at the same time. It's done the analysis, and its observations are quite stark. It says that the share of total net worth of the top 1% is a metric that has been on the rise since the late 1980s. It talks about the steadily increasing M2 money supply, and also the fluctuations and noticeable increase in the sticky consumer price index. And its analysis is telling. It says the increase in the share of total net worth of the top 1% appears to coincide with the growth in the M2 money supply, especially in recent years. This might suggest that the top 1% are benefiting more from the expansionary monetary policies and the resultant increase in asset prices. It also says from the visual examination, the growth in the share of net worth and the M2 money supply doesn't perfectly align with the sticky CPI, which reinforces the idea that much of the increased money supply might be flowing into assets, benefiting the wealthy, rather than typical consumer goods and services. Now, some of that could just be from the foundation model itself. It might not be reliant on the data. But here it does some additional calculations, and it calculates the correlation coefficients between the datasets. It runs the Python code to actually do the analysis, and it comes up with an interesting addition. The correlation coefficient between sticky CPI and M2 money supply is negative 0.724, a moderately negative linear relationship, as we observed earlier. The correlation between CPI and total net worth of the top 1% is negative 0.914. This strong negative correlation suggests that as the share of total net worth held by the top 1% increases, the sticky CPI decreases or grows at a slower rate. This could be indicative of wealth accumulation in assets rather than typical consumer goods and services. And then its final conclusion, which I think was quite telling, is that the correlation between the M2 money supply and the share of total net worth of the top 1%, the correlation coefficient is approximately 0.805. That strong positive correlation indicates that as the M2 money supply increases, the share of total net worth held by the top 1% also tends to increase. This relationship also suggests that expansionary monetary policies might be benefiting the wealthy disproportionately, potentially through asset price inflation. So here's its conclusion. It says in summary, the data suggests that the top 1% may be benefiting from increases in the money supply, especially in the form of asset price growth. The rise in asset values might not be fully captured by the sticky CPI, which is more focused on consumer goods and services. As a result, while the broader population might not see rapid inflation in their everyday expenses, the wealthy might be seeing significant growth from their net worth due to rising asset prices. This dynamic can contribute to growing wealth inequality. So there we have it. I wasn't expecting to go down that rabbit hole. I certainly didn't expect it to do that second order of analysis and work out the correlation coefficient. But given it did, its analysis actually makes a lot of sense. But watching it do the analysis, watching it think slowly and perform those calculations makes me reimagine what this whole AI trend is about. So if you've made it this far, well done. So what can we conclude from all this? Well, for starters, it's impressive, but performance was varied. Simple forms of data performed very well, more complex forms of data in multi-tabbed Excels really struggled, but the good examples are mind-blowing. The failures are embarrassing and annoying, and to be honest, I cut a lot of them out. And the worst part is that, for now at least, it's very much flying blind when it comes to critiquing the visual chart outputs. It's very good at understanding data, writing Python and code, and taking those outputs and understanding them, but it can't see, and I can. And that makes it a very different type of experience when you're working alongside an AI. In terms of the benefits, it's hard to quantify right now. Making this episode took an insane amount of time. It certainly wasn't quicker than me using my own Excel skills to just analyse the data. And it also doesn't compare to any of the human published analysis that's already out there on these open data sources. That being said, the contextual analysis from ChatGPT's massive foundation model and that training data set provides some insightful commentary. That is, once you've identified interesting patterns or trends for it to focus on. If you've been watching this on YouTube, you probably noticed a few times I had to keep dipping into the source code or looking at the Excel and figuring out how to debug it. The time it took and the skills it needs to actually analyze this can't be ignored. The impact on the workflow is something that I need to watch much closer. And as you noticed in that final example, prompt engineering matters. I won't go into it in this episode. I think it warrants a lot more time to explain what prompt engineering is and how these models handle that type of input. But as you saw, the context prompt of telling it was a data analyst, and then the follow-up suggestions that I've asked really made a big impact on the overall output. And at times, being a micromanager and telling it exactly what to do had the desired effect, even though it was infuriating. But what's the final takeaway? You probably don't realise it, but you just watched an AI demonstrate System 2 thinking. You might not have known what System 2 thinking was before this episode, but hopefully now you do. We as humans have dual modes of computation. Some of it's quick, instant, intuitive, keeps us alive, and sometimes comes out with just whatever's top of mind, without even thinking. But we also can do deep, rational thought and critical analysis. It's slower and it's energy intensive, but it's what makes us, us. And I really think what we're seeing with AI now is its ability to do System 2 thinking. And sure, it's different. It reasons in a very different way to the type of decision making that Daniel Kahneman and Amos Tversky identified and observed in all of their Nobel Prize winning analysis. But nonetheless, it's using what skills it has, writing Python scripts, plotting charts, calculating coefficients, and it's calling upon its deep knowledge and training dataset to think and to come to conclusions about things. I think that's quite an interesting development that we need to pay attention to. Anyway, that's all for this episode. If you're interested in learning more, as usual, I'll share links in the show notes. If you enjoyed this episode, please leave a review on whatever podcast app you're using or however you do it on YouTube these days. And if you want to get more involved in this type of conversation, feel free to join the Discord. I'm going to try and discuss more of these topics at length. This episode was written, recorded and edited by me, Jonathan Tipper. The theme song is by Jonathan Mann, and the backing soundtracks are from Epidemic Sounds. All the artwork was created using Midjourney. Thanks for listening, and I'll catch you next time.
The attention economy pits you against me. Money makes no sense these days, and the robots are taking jobs. The planet is in peril, but we can set us free. Put our brains together if we lead with our hearts. Gotta take back